Ba-dum bum, ba-dum bum, ba-dum bum, ba-dum bum, ba-dum bum, ba-bum, 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 ba-bum. Alright kiddos, this is video 10.2, Prime Factorization. That's right, Prime Factorization. We got to talk about two things. What is prime and what is factorization? Well, prime is any number that cannot be divided into smaller numbers. It's prime. Its only factor is 1 in itself. For example, 1, 2, 3, 5, 7, 13. Those are all prime numbers. They have no other factors. In factorization, any two numbers that can be multiplied together to make another number are the factors of that number. So for example, a factor of 8 could be 4 and 2 because 4 times 2 equals 8. So we're going to find all the prime factors of a number. And there's two methods that we're going to use. The factor tree and the ladder diagram. So we're going to teach you how to use both of those for prime factorization. So copy down the title, copy down both of these, and do me a favor and write down what you think prime means and what you think factorization means. What are factors? What is prime? If you don't remember, just rewind me and listen to the smooth voice describe both of them. Use a factor tree to find the prime factorization of 240. What is that I doing there? Let's get rid of that. Sorry, Mr. Paper made this, so if there's any mistakes, just let him know when you see him in class tomorrow. So, prime factorization of 240. Alright, we're going to use the factor tree, and the way we're going to do this, you're going to start by writing the number 240, and now I'm going to find a prime number that is also a factor of 240. Well, guess what, kiddos? 240 ends in a 0, meaning that it has a factor of 5 and a factor of 2, both of which are prime. Let's start with the smaller number. So 10. Let's just go ahead.
10.
10's not prime, Miss Sorrels.
Oh, you want to start with the prime one?
Duh. God, Miss Sorrels. I don't know how you'll deal with her. Alright, so if 2 is a factor of 240, then, and I divide 240 by 2, what's going to be my other factor here? 240 divided by 2 is going to be 120. Alright. Now, this one ends with a 0 as well, so I can put another 2, and 120 divided by 2 is 60. Alright, now when I get a prime number, I'm going to circle those. So that for sure is a prime number. That's a prime number. 60 is not prime, and it ends with a 0, which means it's divisible by 2 again. Alright. Now, 15 will go into 32 times. See, it ends with a 0, so I can put 2 again. And I'm going to put 15 here. Now 2's prime. Alright, now I got 15, and 15 is divisible by, not 2, because it's not an even number, but the next prime number would be 3. And it is divisible by 3, and it's divisible, 3 times 5 is 15, and 3 is prime, and so is 5. They're all prime. So now we're going to write the prime factorization using exponents. Alright, so my first prime number is 2, and count them up. I've got 1, 2, 3, 4. I've got 4 of them, so it's 2 to the 4th power times, I've got a 3 there, I've got 1 of them, times 5. And that's my answer. 2 to the 4th power times 3 times 5 is the prime factorization of 240. Notice all the numbers are prime. 2, 3, and 5 are prime. And if I multiply all of these together, I will end up with 240. Make sure you get all of this copied down. Use a ladder diagram to find the prime factorization of 132. Alright. So, let's start with the ladder diagram. We're going to find the prime factorization, so all the prime factors of 132. So I start by writing 132, and then I do one of these. 132. All right, and the factors of 132. Well, it ends with an even number, so one of the factors has got to be 2. So 132 divided by 2. Come over here and I do my long division. All right, 2 goes into 1 0 times, but 13 6 times. Drop my 2 there. 6 times, so 66. So what I'm going to do is write a 66 right here. 2 times 66 is 132. Alright, and I'm going to drop down and make one of these actions right here. It's an even number again, so I know that I can factor out another 2. Alright, and that would be 33. Alrighty, so I'm going to drop it down. And 2 will not go into 33, but 3 will. Alright. Okay, so 33 is divisible by 3. That's a prime number. And 3 times 11 gives us 33. And just to kind of finish this off, drop this down. And we say, all right, it's 11 and 1. And so our prime numbers are 2, 2, 3, and 11. So the prime factorization of 132 is 2, and I've got 2 of them, times 1, 3, times an 11. We don't include times 1 because that doesn't affect the outcome. So all of these numbers are prime. 2 is prime, 3 is prime, 11 is prime, and if we multiply them together, they will equal 132. Prime factorization. Copy that down. Alright, so here are some prime divisibility rules. Go ahead and copy these down, but just to give you an example, any number that ends with the 0, 2, 4, 6, or 8 is going to be divisible by 2. So for example, I don't know, 2,342, it ends with a 2. So I know it's divisible by 2. The digital root, 3 is the digital root is divisible by 3. So for example, if I have a number like, I don't know, 1,230, if I just add all these digits together, so I do 1 plus 2 plus 3 plus 0, that equals 6. And 6 is divisible by 3. Meaning that 1,230 is also divisible by 3. So just adding all the digits together and seeing if that is a multiple of 3. And if the sum of all the digits is a really big number, you can find the sum of those digits and it will still be divisible by 3, then the digital root works still. So for example, if I have like a 996, if I add all the numbers together, 9 plus 9 plus 6, that's 24. That's 24. And if I add all the numbers together for the each value together, the 2 plus the 4, I get 6. Since 6 is divisible by 3, 24 is divisible by 3, and so is 996. They're all divisible by 3. So that's how you figure out the rule for 3. 5, any number that ends with a 0 or 5, so I mean, you could literally have 1,272,345. That number is going to be divisible by 5 because it ends with the 5. All right, 7. You just got to try it out. You have a number, you're not sure if it's divisible by 7. There's no real steadfast rule, so you just gonna have to try that out. And then finally, 11. With 11, if I have like 22, if it's a 2-digit number and the numbers are the same, it's divisible by 11. 3 digits, if I have a 1, a 3, and a 2, I take the 1 and the 2 and add them together. So 1 plus 2 equals 3, which is the middle digit. So it's divisible by 11. If I have, I don't know, 600 and, well, that wouldn't work. 600, and 82. I add the first and the last digit together and I get 8. Alright, so it is divisible by 11. Okay, there are other rules for 11, but we're just going to keep it simple. That's it for the video. Make sure you write everything down using notes for the Google Doc. And we'll see you in class.